Bueno, buenos días a todos. Estamos más una vez empezando una capacitación de SIRGAS a toda la comunidad, a todos amigos y compañeros que están acompañando SIRGAS en estos canales de eventos virtuales. Pero para los próximos días tenemos un taller sobre la instalación y operación de estaciones GNSS activas permanentes. Entonces, hoy, en los próximos 3 días de la semana próxima, tenemos en el mismo día, en el mismo horario, las presentaciones hasta miércoles. Hoy tenemos la participación a través de una invitación que hicimos a UNAVICO, a Gnss, por su trabajo que tiene hecho en las estaciones de América Central y Caribe. El tema de hoy será las etapas y detalles de la instalación de una estación GNSS permanente. Antes de empezarmos, yo gustaría de agradecer a Gnss por su participación, por aceptar nuestra invitación, por estar con nosotros hoy y pasar todo su conocimiento que tiene en el establecimiento de estas estaciones permanentes, que son de suma importancia para el marco, nuestros marcos de referencia. Muchas gracias, Eni, por aceptar nuestra invitación. Bueno, está con nosotros hoy también el nuevo vicepresidente de SIRGAS, Federico, y que estará nos acompañando. Lamentablemente, Diego tuvo que se afastar de higiene por cuestiones particulares y por la compromiso que higiene de Argentina tiene con SIRGAS. Federico sigue en la vicepresidencia de SIRGAS y estará acompañando hasta el término de nuestro mandato. Federico, ¿gustaría decir algunos bienvenidas a los colegas, por favor?
Sí, cómo no. Bueno, bienvenidos a todos. Muchas gracias, Sonia, por la presentación y bueno, será un placer y un honor acompañar al comité ejecutivo en todas las tareas que hay que realizar y particularmente el deseo a Diego de lo mejor en la nueva etapa y continuaremos con todo su esfuerzo y la energía que le ponía a esta tarea.
Ok, muchísimas gracias, Federico. Bueno, podemos empezar entonces, Annie. So Annie, the floor is yours. You can start, please.
Thank you all very much for coming to my talk. Good morning and buenos dias. My talk today is going to be on the installation of permanent GNSS stations. My name is Annie Zano. I work for UNAVCO, where I am an engineering manager with the Network of the Americas, which is a network of permanent GNSS stations spanning from Alaska down through the Caribbean Basin region. And I'm the manager who focuses on the Caribbean Basin region. So that would be the stations that are located on the Caribbean islands throughout Central America and Northern South America. First, I'd like to say a little bit about UNAVCO. We are a nonprofit governed by a consortium of universities, and we're funded by the National Science Foundation, NASA, and the USGS to operate the Gauge facility. We support the geodetic community through operating and maintaining the Network of the Americas and other permanent networks, providing equipment, training, and engineering support to researchers, geodetic data archiving, management, and providing data products, and education and outreach support for the existing and future geodetic community. I'd also like to mention that by the end of this year, UNAVCO will be changing its name. We are going to be merging with an organization called IRIS, which is our sister organization, also funded by the National Science Foundation. Their focus is on seismology, so we will be a joint geophysics facility called the EarthScope Consortium. If you'd like any more information about EarthScope, there's a website down here that you can visit. So as I approach this this talk today, I decided to structure it as just building a permanent GNSS station from the ground up. So first I'll discuss just a very basic overview of all of the different station components. And then we'll start at the beginning. So we'll try to choose a really high quality station to get good data from. And then we'll choose the appropriate type of monumentation to go with that station. And then we'll talk about antennas and then receivers and telemetry to get the data back to the data archive. And then I'll talk a little bit about the station infrastructure and some of the preventative maintenance that we can do to try to limit some of the environmental problems that we might run into. All right, so starting with the components of the GNSS station, when you first approach the station, you'll see the monument and antenna here, and then the enclosure and power system. This is a very standard installation for the Network of the Americas. Here we have a choke ring antenna covered by a radome on a monument. This is called a short drilled brace monument, which I'll talk about more in a little bit. You see the antenna cable coming down right here. That will come in through the bottom of the enclosure. And inside the enclosure, we have the GNSS receiver right here. For the power system, we have 4 100 amp hour batteries, 2 85-watt solar panels, and then a solar charge controller here that's part of this electronics board. For sending the data back to the archive, we have a cellular modem right here and a little cellular antenna mounted on the pole right here. There's going to be a lot of differences between this station and other stations depending on the specific needs of the site. This is an appropriate power system for anything in the mid latitudes and low latitudes, and the cell modem obviously is only appropriate where there's actually cell service. So now starting with choosing where we would want to put our GNSS station. There are a lot of different factors that go into choosing a really high quality station location. And the first factor that we want to look at is making sure that we choose a location that has very good data quality. And I'm sure a lot of you are familiar with some of these principles. Firstly, we want to choose a place that has a good sky view so that from horizon to horizon, our antenna is going to be able to see the satellites. So that means cliff faces, buildings, and vegetation are really important to stay away from. And since we want a long continuous time series lasting hopefully decades, it's important to look at the size of the vegetation in the area. Small trees are going to grow into big trees. So we want to make sure that that's not going to be a problem through time. The next factor is the ground solidity. We want to make sure that that when we're measuring the movement of the Earth, it's the movement of the tectonic plates in the area. It's not just the movement of the local ground surface and soil. We do have monument styles that work very well in unconsolidated dirt and sand. However, if there's something like underground water that's flowing past that might be destabilizing that ground, that would be a problem. We've also had problems with stations that we've accidentally put on the toe of a landslide, and that slow creep meant that we were only measuring the creep of that soil rather than the actual tectonic motion. Multipath is important too. If we have any reflectors in the area, then we might be accidentally seeing the reflected signal coming from the satellite rather than the direct signal. And so that will introduce noise into the data. And the last thing that I'll mention today is frequency interference. If the station is located in a place that has a lot of other transmissions coming through, some of those might be on frequencies that are very close to the GNSS frequencies, and that will also introduce noise into our data. So the next factor that we want to look at for choosing our station is the data access, and making sure that that we're going to be able to reliably get data coming back from the site. The first and most important part is having good, consistent power. As soon as the power goes down at the site, then the station is going to go offline. This site right here is a station that was on AC power, and somebody unplugged the just the main AC power. So we ran on the batteries for about a week, and then the station went offline. Consistent communications is also really important, knowing that we're going to be able to get data back from the site reliably. And it's also important to think about the worst case scenarios here. So in the event of, say, a large earthquake, you know, if you're using something like the cell network, do you need to worry about, excuse me, whether that network is going to be overloaded, and in that case, the station communications might go down. So if it's a really critical site in situations like that, then you may want to consider duplicate comms, or just making a choice that's very robust in that environment. Site security is a very important one that I think all of us have experienced at one point or another. I really like this photo because it shows you know, the mitigation that you can try to make to prevent damage to the site. The engineers here use spray paint to try to camouflage the box and make it less visible to potential thieves. But this obviously also didn't work, because you can see here the solar panels have been stolen, so the site was offline. And this is something that we really want to prevent, not only for the data downtime, but also because it's really expensive to constantly be having to replace your equipment. And the last factor we'll talk about for the station placement is station longevity. It's really important to, as I said before, have a continuous time series that hopefully will last for potentially decades. So if you choose to put your site in a place where they may plan for future development, or the landowner may sell that property to someone who doesn't want your station there anymore, then that's going to interrupt the time series. So some good options that we've had luck with in the past, airports are really fantastic, as you can see here. Any government-owned land or university-owned land tends to be a stable place where we can get those really long-term land use permits. Wildlife sanctuaries and other places that have a protected status that won't allow future development. All of those are really good places, but also, you know your own site location better than I do, better than anyone else does. So you know what the most appropriate place is that will allow you to have that long-term commitment. All right, now that we have chosen where we're going to put our station, the next choice that we need to make is what kind of monument is appropriate for that site. And I'm not going to discuss these charts in detail, but they're good references. But these are all factors that will go into that decision-making process. Obviously, we want as high stability as possible. And we need to look at what type of substrate we're going to be putting our monument into. You know, is this a really solid bedrock, or is this more of a soil or a crumbly material? So we want to choose the most stable type of monument for our particular substrate. However, I think for every one of us, cost is a major factor here as well, and sometimes the best possible monument that you might choose is just going to be out of your price range, and that there are other options as well that are pretty great too. So I'll start talking about some of these monument types in more detail. And the first type of monument here is the deep drilled braced monument, which is commonly abbreviated as DDBM. And as you see, there is a drill rig that's involved here. And we start by drilling 5 holes that are 10 to 15 meters deep usually. So you can see where these X's are. We have four holes laid out in a square, and those are drilled in at a 35-degree angle. And then we have 1 hole in the center here. These are cased by the drillers with PVC, And then we put stainless steel pipe going down into these holes. And then we add rebar into the center of the pipe for additional reinforcement. And then we grout all of the holes in place and weld the conjunction of these 5 pipes together, and then weld an antenna mount on the top. And then this is what the final monument structure ends up looking like. And this is pretty much the most stable type of monument that that we can possibly drill. And it's fantastic for a variety of different ground conditions. This is good for both unconsolidated material as well as bedrock. And it's a very durable design that lasts for a very long time, but it's also very expensive. It also requires being able to bring a drill rig out to the site, and they're going to be doing grouting, and we'll also need generators for the welding. So this is a relatively large construction footprint. So we need to be able to have the sort of access that's necessary to be able to get all of that heavy equipment out to that site. So this is not an ideal option for mountaintops or down 4-wheel drive roads or something like that. But if you're interested in pursuing this option for one of your sites, we have the technical specifications on our website right here, and that also includes instructions for the drillers. The next type of monument that I'm going to talk about is actually two different monument styles, the short drilled and short driven braced monument. And the final product on both of these looks exactly the same. The only difference is how we get these pipes into the ground. If the site has bedrock within ½ a meter of the ground surface, we'll drill it in using this this Hilti hammer drill right here. But if it's dirt and unconsolidated material, it'll actually just be hammered into position. And these holes are about 1.5 meters deep. We have only 3 legs this time rather than 4 at an angle, and then this one vertical. And just as before, where these pipes all come together, we weld them all together, and then weld the antenna mount on the top. And then this is the final product here. This type of monument makes up, I would say, the majority of the monuments in the network of the Americas in the continental United States, at least. It's a really great compromise of a very high stability monument that's much more affordable than that deep drill brace monument that we just talked about. It's very adaptable. If you're not entirely sure how deep the bedrock is, you can, start hammering in until you can't hammer in anymore, and then you see that it's bedrock, and then you can switch over to drilling instead. And all of the materials you would need for this monument you would already have on site there. It's a very stable and durable monument. It's definitely not quite as stable as the deep drilled monument, especially when you are installing this in unconsolidated material. You do still need to bring your heavy duty hammer drill and generators for welding and a large variety of other tools to the site. So this is still not a great option for example, a site that you need to hike into, but it's all around a really great and much more affordable option. And by the way, the costs that I quote here, these are all in US dollars. And I also recognize that country to country, the prices are extremely variable and often quite a bit more expensive depending on the availability of materials. So I would just use this as a rough starting point, not actually for budgeting purposes. But if you'd like the technical specification for both of these types, we have them on our website also right here. The next type of monument I'll talk about is the polar mast. As you can see, this is one that we commonly use in Antarctica and Greenland and places like that. And the reason we use it there is because typically these installations are done by helicopter or small fixed wing aircraft. So we can't take a lot of heavy generators and welding equipment with us as easily. So this whole piece is bought as a single unit and taken out to the site. And we actually do all of our antenna orientation and leveling and everything through the installation process. So we have a jig right here that we use to make sure that the leveling and orientation is exactly right. And then we drill into the rock here, and then we use little nuts as standoffs to get that leveling exactly where it should be. And these are expansion bolts. So then you just hammer them in and they expand out and lock it into place. And then we use epoxy as well to further lock it. So this is really a pretty solid monument style that requires very strong and stable bedrock, but it's also a good option. As I said, there's no welding or generator needed, so limited tools. It's also a relatively fast install. It only takes an hour or two rather than the full day for the short drill brace monument, or multiple days for the deep drilled. The other thing to mention is that the rock surface really does need to be moderately flat. This wouldn't be an ideal choice for a very sloped area. And the monument, the bedrock does need to be very strong. This wouldn't work as well in, say, a more crumbly sandstone. This is very appropriate for a very strong basalt or something like that. And the last type of monument that I'll talk about today is a building mount. And you can see that there are many different styles that we've employed in different places to mount these to the roofs. It's not a single design necessarily, though there are designs out there. But whatever seems most appropriate for that particular roof style. And this is something that UNAVCO doesn't install as often, but throughout the Caribbean Basin region, we have a lot of local collaborators who have very long, they have sites that were installed a very long time ago. And so we have a very long continuous time series, and it's fantastic to be able to maintain that. And we find that the data quality from many of these sites is really great. The most important part here is to make sure that you have an antenna mount that is strongly coupled to the building, and then that the building is strongly coupled to the ground, so that you ensure that you're only measuring the ground movement, not the movement of the building itself. So ideally, you would want to choose a building that's made out of concrete or masonry and that has a really strong and deep foundation. Ideally, this would also be only maybe 1 story tall. We can get away with 2 to 3 stories, but definitely don't want a situation where there's going to be any movement of that building. So these first 4 photos are all really great monument choices here. Please do not do this. This was a site that was originally installed for precipitable water vapor, not for geodetic research. But yeah, you can see the monument at the top of this tower that's mounted on top of a building. We saw 5 centimeters of sway back and forth in the wind at this site. So really not an ideal one. But yeah, if this site is chosen well, you do have very high stability. However, it's not always possible for us to really assess the structural integrity of the building where we're going to be installing. So it's a little bit unknown how strong it's going to be until you start seeing the data and see the quality of that. Other really fantastic things with this building mount, it tends to be very low cost and it can be installed very quickly. Also, often you can use the communications and power that are supplied for the building itself. So, in some cases that might even be free, which really reduces those costs. This is also a higher security option, especially in cities. Roof access is often more restricted. So, it prevents people from getting up there and stealing your equipment. Often just the antenna will be on the roof, and then the cables will just run inside the building, and that's where the electronics will be located. And so there's going to be a lot better environmental protection of those electronics and a lot less corrosion of those connectors. And so it might make your equipment last a bit longer there. So yeah, this is also a really great monument option. So whatever type of monument you use though, hopefully since that monument is going to be staying for a very long time, there will come a time when you need to change the antenna. And we need to ensure that we have a way to maintain the exact positioning and orientation of the antennas between antenna changes, so that that phase center calibration is exactly the same. There's two styles that I'm going to talk about today of antenna mounts. The sign mount here is the one that we typically use at UNAVCO. This is designed and built by SCEC. It's kind of expensive. It's about $850 US, and this type of antenna mount allows for the sign tall radome, which I'll talk more about in a little bit. Another slightly cheaper option is the Seco 2070 series. There are a few different styles of these available, but these might be a little bit easier for many of you to purchase because it's more of an off-the-shelf mount that can be acquired from survey companies. So this is also a good reliable option as well. And this requires you to use the sign short radome. Now moving into antennas, I want to start by saying that there is a huge number of really great antennas out there, and many of them are great options for these permanent GNSS stations. However, any antenna that you choose, if it's going to be incorporated into the SIRGAS continuous network, it needs to be listed on the IGS antenna official lists, and for each of those there's a code that corresponds to that. So you can look that up on the IGS website. I'm going to talk about 3 different antenna styles that we commonly use at UNAVCO, but like I said, there are other ones out there that you're also very welcome to explore as long as they're compatible. So the first is the choke ring. There are many different manufacturers of this. Trimble, Ashtec, StoneX has one now. There's lots of others out there. And this was the original standard of the geodetic research community. These are relatively high cost, sort of $6,000 to $10,000. And typically we do prefer to use them with a radome that protects this low noise amplifier in the center here. Another really great option is the Zephyr Geodetic 2 or Zephyr Geodetic 3, manufactured by Trimble. These are more moderate cost than the choke rings in general. They're also very high quality antennas, and they're environmentally contained, so you don't need to use that radome with them. The last one that I'm going to talk about is the Septentrio Pola NT. This is quite a bit cheaper, so it might be much more affordable for some of you. And it's also a very high quality antenna that's environmentally contained. And one of the places that we really like this is higher in the mountains and in more polar locations where there's a lot of blowing snow. We often see rime ice buildup on the side of the antennas. And that rime ice actually causes distortion of the signals coming from the satellite as they come into the antenna. And we actually see noticeable position offsets. So you can imagine how on a choke ring antenna with a big radome on top of it, you might get quite a bit of rime ice buildup on the side of it. Where for something much smaller like this, and this is probably only, how big is it? Like 8 inches across, maybe. You just don't have as much space to build up that rime ice, and so we see that problem much less with these. Since the choke rings are so popular, I'm going to talk about those a little bit more. First, I'll talk about these radomes that I mentioned before. One important thing about these radomes, that these are sine radomes. These are the only radomes that I'm aware of, at least, that have the appropriate IGS calibrations and are fully compatible with the IGS standard. So when you're choosing your antenna identification in your receiver, there's a drop-down menu, and you'll choose the appropriate code for your antenna, and then it will be followed by either none, which is no radome, SCIS, which is for the short dome, and then the other option is SCIT for the tall dome. So the short dome here is compatible with the SECO mounts that I showed you before, and with a lot of other antenna mount styles. The problem with these is that it's not fully environmentally sealed. There are lots of drainage holes in the bottom of these rings, and those drainage holes allow insects to go up inside, and blowing snow or even sand can blow up inside and then fill up the space here, and it doesn't have a great way to get out. We see a lot of wasp nests in particular really filling up the space, and then when snow blows up in here and we get ice accumulation on top of that low noise amplifier, we see the same position offsets that I mentioned before with the rime ice. So we sometimes just plug the holes in the bottom, and that's been a pretty good solution too. The tall dome is only compatible with the sine mount, but it is fully environmentally sealed because it has this base plate across the bottom as well. The other thing that I'm going to talk about is this low noise amplifier. I mentioned before that the antenna itself is very expensive, $6,000 to $10,000. But one option, if you want to, for example, upgrade from GPS to full GNSS, or if the antenna fails and you need to fix it, you can just replace this low noise amplifier. Talisman makes an LNA for both the Trimble and the Ashtec choke rings. And those UNAVCO paid for the IGS calibrations for those, so they are on the official lists and are allowable. This LNA can be replaced by your own local technician. Ideally, this would be in a sealed laboratory, but if it needs to be done out in the field, that's also a possibility. It doesn't take very long. It's not very difficult. And yeah, it's a lot lower cost. It's only about $800 US for this assembly. Now moving on to receivers. Once again, there are a large number of really great receivers out there. I'm just going to talk about 4 that we have within the Network of the Americas and other networks that UNAVCO operates. The first is the Pola RX5. By Septentrio. It's a full GNSS receiver that we have very heavily tested in-house. And this is the new standard that we're putting into all of our stations. I'd also like to mention that if you work for an organization that is a UNAVCO community member, we do have community pricing available. So if you look at our website, you can access those discounts. Another receiver that we still have a number of in our networks is the Trimble Net R9. This is no longer officially supported, but it's still a really solid receiver that we've really had great luck with. Many of these are GPS only, but they can be upgraded to full GNSS. The process for doing that is relatively complicated and time consuming though. But yeah, we still have a lot of these in the Network of the Americas, and we also use them for campaign work. So they're great receivers. We still have some of the old Trimble Net RSs. This is our old standard workhorse, and it is GPS only, but we're in the process of transitioning those out. And the other receiver that I wanted to mention was the Resolute, which is manufactured by a company called Alert Geomatics. And this receiver is a specialized one that's pretty great in certain circumstances. It actually has a Septentrio board in it, but they strip down all of the extras on it so that it's very low power. So it's only about 1 watt. So that makes it much better in certain installations where power is a concern. It also has an integrated comms module, so you can choose between a radio module, a cell modem, and an Iridium modem, and that's integrated into the system also. And that does increase the power usage a bit, but still not very much. The only downside to these is that you can only choose 2 constellations, but you can choose any 2 constellations you want, whether that's GPS and GLONASS or GPS and Galileo or whatever you prefer. All right, now I'll change gears and we'll talk a little bit about telemetry. We've got multiple different types of telemetry that we can look at. One is a DSL connection, just a direct Ethernet connection. Then we have the cellular modems. Vsat is a great remote option. And then we also have BGANs like this one right here, and Iridium, which I don't have a photo of. And another option in all of these cases is if your central comms hub that you're using to send the data back to the data archive is located in a slightly different place than your station is, you can always set up a radio link between your station and that communications hub. And I'm not going to talk about that in great detail today because we just don't have enough time. But in terms of choosing which of these options is best for your site, first and foremost is what options are available at your site. Do you have a direct connection? Do you have cell service? Another very important part is how reliable it is, since we want to make sure that we can get that data back very consistently. Throughput is important too. The 30-second data doesn't take a lot of bandwidth, but if it's important to have a real-time data stream, then that starts adding up a bit more. Power requirements are also important. The BGAN in particular is very power hungry, where some of these other options are, they use a lot less power. Cost is a really huge factor for all of us as well. And then ability to get past firewalls is also an important factor that mostly just affects this direct Ethernet connection. So I'll talk about each of these in a little bit more detail here. This direct connection is a fantastic option for these building mounts and city sites. And there's sort of 2 ways that this can be handled. Either you are plugging into an existing internet connection that's maintained by the building owners, or you are setting up your own account with the internet service provider and paying for that. And the first option is often free, and the second option is usually a relatively moderate price. But if that line is operated by the building owners, they may have an IT department that has set up firewalls and is controlling those connections. So you have to work with them closely to make sure that they can open the appropriate ports for you and that they can assign you that static IP address, which is really important. And this is a really reliable option, except that those IT departments often make changes without telling us, and then we lose connection to our sites. So just maintaining that good relationship is really important here. Next option I'll talk about is cell modems. Cell modems are my favorite wherever we can use them. So that would mean any place that there is cell coverage. The price for these plans is variable by location, but it's usually a relatively moderate price. And this is just a really reliable option, all in all. That static IP address does become a potential problem here, and there are 2 options that you can pursue. In some places with some cell providers, you may be able to request a static IP address and pay a little bit extra for it, but for some carriers that's just not an option. And the thing that we generally prefer, especially if you have multiple stations that you're maintaining, is to create a VPN tunnel from your organization, and then you can assign device IPs, and then you can maintain that static IP address without having one assigned to the outward facing section of that cell modem. By the way, I'm seeing people raising their hands, but let's just wait until the end to do questions, if that's all right. Next one is the Vsat. This is a really great option in more remote locations, and it's definitely the lowest cost of the remote options. The problem that I've really seen with these throughout the Caribbean, especially in salty areas, is that there's a lot of metal on this that's susceptible to corrosion, and so the failure rate of these tends to be high in those places. But there are other places that are more inland, and I know that we have a lot of sites in Alaska that have a lot of success with these Vsats, so it really is a perfectly great option too. Another thing to consider is that if you are coordinating with local collaborators on assisting with repairs, they really need to be experts in Vsats to know how to repair them. These are really finicky and challenging to work with, so that's a challenge too. Moving on to BGAN and Iridium. This is probably the last ditch option if there's nothing else that's working well for you. It's good in these high corrosion locations because it is just, a relatively low profile plastic box that's installed outside the enclosure, and all the rest of the electronics are inside. The cost on both of these is very high, on the order of $400 a month. So that's prohibitively expensive for many organizations. But there may be places where you need this regardless. Iridium is really great in very high latitudes because the satellites do pass over the poles. The Iridium also has much lower power consumption. The BGAN is very high power consumption, so you'll need to plan to either put out a dozen batteries, or sometimes we'll put it on a timer so that the device is only online for an hour a day and just pushes through that daily file. All right, now moving on to some of the different environmental mitigation that we can do to prevent damage to the sites. I was specifically asked to focus a little bit on surge protection, since lightning strikes and static discharge and things like that are very common at some of these sites. And we use 4 different types of protection here. The lightning sponge, this guy right here, is a very important one for lightning strikes, and this protects all of the grounded electronics. So it's mounted on the outside of the enclosure here, and then the wires come in and they go into this terminal block, and then they go into the main electronics board, and that provides protection for the GNSS receiver, and any communications devices that you have. It's not going to prevent against direct strikes. There's nothing we can do for those. You're just going to have a pile of melted metal. But it will protect against nearby strikes that would otherwise damage the equipment. The next thing that we use is this coaxial inline protection. This is manufactured by a company called Huber Schuner. And these protect the internal electronics from charges that are coming from the antennas that are outside this enclosure. So you see we have 2 here. One is for the GNSS antenna, and the other is for the communications antenna. And there's this little gas cap right here, and that needs to be changed every 2 years, or more frequently if you're seeing a lot of of static charges and buildup in the area. The other two things to mention are the Ethernet surge protection and the AC power surge protection, which I don't have photos of here. But the Ethernet surge protection is especially important because sometimes we'll get full protection for the grounded electronics coming from the this lightning sponge, but the charge can still come through that Ethernet cable. And it's very common for us to see the Ethernet ports on the GPS receivers will fry. So that's just some protection for those. Now I'll talk about some of the problems that we specifically see in tropical or coastal regions. Obviously, one near and dear to my heart is hurricanes. And the best thing to do here is just making sure that you've got a really strong enclosure and other infrastructure to protect against that wind damage. So you can see this this little bunker area. This was built by the University of West Indies Seismic Research Center. And you've got really good reinforcement for the solar panels up here. The other important factor is any exposed cabling needs to be strapped down really well with hose clamps or zip ties or something like that. Because if those cables are flapping in the wind, then they'll often shear off where the connector comes in. It's also very important to have your site on high enough ground that it's well above the storm surge. We recently 2 years ago lost a station in Grand Bahama that ended up several meters underwater. So that's definitely something to consider. Insects and rodents are a problem pretty much everywhere except for Antarctica. Most important part is to just seal all of the potential entry points. But there's always going to be some insects that make their way in. And so there are some deterrents that we can use here. Diatomaceous earth is a really great thing to sprinkle in the bottom of the enclosure. And that will prevent lots of different insects from making colonies inside your enclosure. As you can see from the site in the Dominican Republic here, we had an ant colony inside our solar controller. Some insects really dislike copper, so a 4 centimeter copper strip, they won't want to cross that. Snails and slugs are very susceptible to this. And one of my favorites is also cayenne pepper. And typically what I'll do is I'll just take a strip of tape, even just duct tape or something like that, and sprinkle the cayenne pepper on the sticky part of the tape, and then use that to cover anything that I don't want them chewing through. And they'll start chewing on the non-sticky side, and as soon as they hit the pepper, they stop. I've used this against mice in my own home. It's very effective. And then the last factor that I'll talk about here is the salt corrosion, which is a very huge problem for coastal sites. Most importantly, using all stainless steel, all marine grade 316 stainless steel for all of the components. And I say here, watch for screws. There's always some little component that somebody didn't think about and made out of some other type of metal, and that of course ends up being the thing that fails. You can see right here, this is where the solar panel frame meets the enclosure post, and this was regular steel, and it's just like paper now. It's just so crumbly. The other thing is to wrap all of the connectors with mastic tape, which is a vulcanizing rubber tape, and that just prevents the corrosion from getting into the connectors and keeps them from seizing up so that you can't disconnect them anymore. And the last thing I'll talk about here is the high latitude and high altitude sites, because they have their own specific challenges too. Deep snow is a really big problem. And we often see solar panels and frames breaking through the weight of very heavy snow. So having a structure like this that can handle that weight is really important. And then here's a specialized monument that was developed ultra strong, but ultra tall. I think this is about 2.5 meters tall. And that's just to keep that antenna above the level of the snow. And then power is another problem that we really run into also, whether the solar panels are covered in snow, or whether you're just at a high enough latitude that you just don't get very much sun anymore. So we need to make sure that we have enough batteries to power through the winter in that case, which might be somewhere 16 to 22 batteries is very common at our sites. And we also recognize that the batteries become much less efficient in cold temperatures. So we usually downrate the capacity by 50% in our calculations to ensure that we really do have enough power to get through the winter. Wherever you're putting your site, it's always great to design a system so that the solar panels are aligned with the sun angle to maximize the power that you can get from them. So here, this is a site in Alaska, and this is in Antarctica. So these are both places where we need that really low angle sun to be coming in. And then I also want to mention we did add these wind turbines to our Antarctica station, so that's just a little extra boost of power there. All right, so that is everything that I have for you today. Thank you all so very much for coming to my talk, and I will stop sharing and we can move into questions.
Gracias, Jenny, por su presentación.
Thank you.
Sí, vamos a empezar con las preguntas y ya tenemos algunas, muchas. Entonces, tú consigues mirar en el cuadro de preguntas y respuestas, ¿correcto? Porque hay algunas en inglés, otras en español. Entonces, ¿cuándo Navico irá a implementar y tener
Yes, do you want me to answer them live or just type the answers, or what would be your preference?
Oh,
Sorry, what was that?
Sí, yo voy a enviar las preguntas a ti y tú contestas, ¿ok?
Okay, sounds good.
¿Cuándo Navico implementará ITRF 2020 o IGS 2020 en su marco de referencia para las estaciones CORS?
That is a very interesting question, and I don't know the exact answer to that. I know that the process, the last time we did it in 2014, took a couple of years. So I wouldn't expect it right away, but yeah, hopefully within a year of now, maybe.
Sí, gracias. ¿Cuál es el típico costo de un monumento DDBM? Yo creo que estuve en tu presentación, ¿no?
Yeah, so I said around $15,000, but this is the one that's most likely to change depending on your location. Alex is in the Dominican Republic, so it's yeah, it's definitely going to be different there than it is here in the US. The materials cost is part of it, but also finding a drilling company. We have been working with the same drilling company for a very long time, and they have that small drill rig, which is a lot cheaper than many of the larger ones. So I would start at 15,000, but it could be double that.
Sí, gracias. Bueno, vamos para la próxima pregunta. En el caso de las perforaciones realizadas sobre roca, ¿realizan estudios de suelo previo para considerar la ubicación? En el caso de los mástiles que utilizan en las zonas polares, si hay una evaluación de estudios de suelo antes de ubicar?
I think I'm not quite understanding the question. Typically we look at the available geology information to figure out what we're likely to find in that area. When we use those polar masts, we typically know that there is good rock there. And for all of our sites, we send someone out to do a recon of the site before we plan our monument installation, so that we know exactly what we're expecting there. Does that answer the question?
Sí, yo creo que sí.
Great.
Pero la próxima pregunta, tú ya respondiste en tu presentación, ¿qué tipo de monumento sugerido para los edificios? Y cómo estos, el mount es nivelado juntamente con la antena. El tipo de instalación,
this is where you use either that Seco mount or the sign mount that I mentioned before, and they have an internal leveling capability. So you have to make sure that your monument is, as close to level as you can get it with a standard spirit level, but it doesn't have to be perfect, because that last leveling will be accommodated by the antenna mount.
Ok, gracias. Bueno, esta es una propuesta de Panamá, que es de Javier Conejo, del Instituto de Panamá, que hay unas 8 estaciones de Unávico del proyecto COCONET. ¿Cómo podemos hacer para aprovechar la información de estas estaciones y además colaborar con el manejo y mantenimiento de las estaciones? ¿Es posible incluir alguna de estas estaciones en la red SIRGAS-CON?
Let's see, this had multiple parts to it. It might be best if you just want to email me, and we can discuss this in more detail. I've been looking closely at the stations in Panama recently, and we are hoping to improve these stations.
Sí, ok. Yo creo que hay interés de otros países también, como República Dominicana.
Absolutely. Mm-hmm.
Entonces, las 3D Showkey-Hingi, las nuevas antenas, ofrecen un mejor rastreo y cancela el multicamino, lo que las antenas tradicionales geodésicas.
Alex, I'm not sure if you're talking about the like the three-dimensional sort of tower structure, like the StoneX choke ring antennas here. But I don't have a good answer for this. This isn't my specialty. I'm sorry.
Ok. Ahora de El Salvador, una pregunta. Actualmente estoy a cargo del monitoreo de la red activa, 4 estaciones permanentes a nivel nacional. Tenemos receptores Trimble Net R9 y constantemente la pantalla se queda congelada. Hasta ahora no he dejado de recibir y almacenar los datos, pero quiero saber si hay alguna manera de corregir este problema. Yo también no sé.
Let's see. I mean, off the top of my head, a hard reset is always a great option to start with, at least. It might depend on whether it's just the screen that's freezing, or whether you can still connect to the HTML page through the Ethernet port. Eric, if you want to email me, we can talk about this more and try to troubleshoot the problems that you're having.
Sí, ok. Eric, y también si puedes copiarnos a SIRGAS también, que sería muy interesante ver cómo son estas estaciones en El Salvador y con la posibilidad de integrarlas a la red SIRGAS con. Bueno, la próxima es la mejor Vsat para Caribe. Yo no sé.
Oh man, Alex, I really don't like using VSATs in the Caribbean. I've switched to BGAN for all of the sites that don't have cellular as an option, and the historical VSAT sites I've been trying to switch over to cellular as the networks have gotten better. We've had very poor luck. Basically, all of the sites that we've installed VSATs at ourselves have needed repairs within a year of the original installation. But this might be a good question for the Seismic Research Center, since they use VSATs at their sites. And actually, the University of Panama, we have some co-located stations with them, and they've been doing a really excellent job at keeping those online, and they operate and maintain those. So so that would be someone else that you could talk to about that.
Sí, gracias, Jenny. Bueno, el recomendable testados, mejores marcas para para estos equipos de protección. Si tienes algunos marcas o
it depends on which type of surge protection of those four that I mentioned. I don't remember the manufacturer of the lightning sponge off the top of my head, but Huber Schuner from Germany is the one that we use for the coaxial cable. And then for the Ethernet surge and NAC power surge, there are a number of great brands out there.
Bueno, la próxima pregunta, si los receptores, estas yo puedo responder, Eni. De marca Soul, puedes integrarse en la red IGS. Bueno, los equipos Soul ya están en la lista de receptores de IGS. Entonces, hay que mirar qué modelo es este de Soul que quieres integrar. Yo sé que en la red SIRGAS hay una estación, al menos una, ya con este receptor. Y la próxima pregunta es de Perú, cuanto a los receptores Trimble Alloy, dos tipos de firmware. Yo conozco solamente, o sea, hay varias versiones de firmware, que el firmware va avanzando con varias versiones, actualizando a cada vez que Trimble disponibiliza, pone disponibilidad nuevas correcciones, nuevos avances, pero yo no tengo conocimiento de dos tipos de firmware. No sé si Eni tiene.
Sorry, I'm looking at this question. This is for the alloy receiver. I don't know much about the alloys because we don't have any of those in our network. But in general, I mean, for a long time, the Trimble alloy had the same firmware as the Net R9. And then at some point they split apart because the alloy has a lot more features than the Net R9. And I don't know about the more modern firmware for the alloy. But in general, my process is always to check the release notes and see what new upgrades have been made and how relevant those are for our use here. So that's probably what I would recommend. But I also, my personal recommendation is to wait a little while, because sometimes the firmwares have bugs. And the last thing that you want to happen is have the bug cause a problem for a station that's really, really far away and not be able to get back to it to fix it. So I wait and let other people find out what the problems are first.
La próxima pregunta es si los operadores de las estaciones CORS deberían sacar la antena antes de un tornado. Y qué velocidad del viento las antenas podrían seguir, resistir en el monumento.
Oh, that's a very good question. So firstly, I don't know of you know, the actual maximum wind velocity that it can withstand, because it's, you know, it's where it connects to the 5/8 thread. It's the monument, it's the mast, it's all of the different parts together. I know that we had a site on Sombrero Island which got a direct hit from Hurricane Irma, and it actually ripped the building mount monument completely off of the building, rather than ripping the antenna off the mount. So that's something to consider there. I actually think that the greatest danger is going to be from flying debris that might come and hit the antenna. In general, it's best if you can avoid having to take the antenna off, because every time you do that, there's a possibility of very small changes to that position. But for protection of the antenna, you know, I don't see that as being a problem, at least. But I probably wouldn't I wouldn't actively do it unless it was a really big hurricane and I was worried about that flying debris.
Bueno, la próxima pregunta también viene de Perú y yo voy a contestar. No sé si Annie tiene alguna observación sobre lo que voy a contestar. Si es recomendable durante el proceso de mantenimiento preventivo desmontar la antena. No hay la necesidad, no desmonte las antenas. Toda vez que desmontamos la antena podemos ocasionar un salto en la serie temporal de las coordenadas. Entonces, no es recomendable que saque las antenas solamente en caso de extrema necesidad. Si Annie, ¿quieres complementar con algo más?
I totally agree with you. If you need to change the antenna because it's broken, or if there's some sort of maintenance activity that is going to make the situation worse if you don't take it off, then consider it. But if it can possibly be avoided, I wouldn't recommend it.
Sí, muchas gracias, Annie. Bueno, la otra pregunta de Randy es mejor que cambiamos nosotros entre SIRGAS, que es más una cuestión de integración de una estación a la red SIRGAS-COM. Entonces, la otra consulta es sobre la antena que está registrada en IGS, CR3, G3 de SOLT, pero el receptor es un net S9 de SOLT. No está en la lista de los 4 mencionados. ¿Sería un limitante de uso de este receptor? Yo creo que sí. Tendría... ok, Annie, puedes contestar.
Oh, I was just going to clarify that the 4 receivers that I mentioned are the ones that we typically use at UNAVCO. But there are many other good receivers out there, and the fact that I have excluded them from my talk does not mean that they're not good quality. I just didn't have time. So yeah, as long as they're in the IGS list, then please don't think that that because I didn't include them, they're bad receivers. But please continue to answer.
Sí, lo más importante es que estos equipos, sea receptores o antenas, tienen que estar en la lista de IGS. Este es lo más importante. Esto contesta la próxima pregunta también. Si quieren integrar a una red nacional, regional o global, hay que tener las marcas de los equipos, sea receptor o antena, estar en la lista de IGS. Yo puedo hablar en mi presentación también con los links donde hay estas listas de modelos de antenas y receptores. Pero hay muchos, como Annie mencionó. Bueno, vamos a la otra pregunta. Sobre el tiempo de referencia. So, Annie, can you read in English to answer this? Sobre la frecuencia de tiempo de los relojes atómicos y cuál es la opción. Recomendación y modelo específico.
I have to admit that this is not something that I'm familiar with, so I don't think that I'm going to be able to answer. Does anybody else on the panel have a good answer?
Bueno, la experiencia que yo tuve son pocas también, pero los mejores tipos serían de hidrógeno. Entonces, esto contesta Sandra. Y el modelo, yo no sé cuál sería, pero tal vez NGS contestaría esta pregunta. Si un ávico tiene material, cómo instalarlos, no sé, si hay un ávico, cómo instalar estos relojes atómicos.
I don't think so. This isn't something that we typically work with.
Bueno, estamos terminando, Annie. Solamente algunas más. Es recomendable el uso de estaciones virtuales de
Well, thank you
referencia.
very much.
Ok. Es recomendable el uso de estaciones virtuales de referencia, Virtual Reference Station, el nivel de precisión es adecuado en la práctica. No sé si esto.
I'm not familiar with the VRS. I'm wondering if this has a different abbreviation that I would know. I'm sorry, I don't have an answer for this.
Sí. ¿Cuál es la máxima profundidad de perforación en suelo no consolidado?
So what we typically recommend, for the, we have the short drill brace monument, and that tends to be about 1.5 meters, and then the deep drill brace monument tends to be 10 to 15 meters. There's no reason you couldn't go deeper if you wanted to, but there's a certain point where the additional benefit isn't really going to add up to all that much.
Okay. En el Polar Mast, ¿qué tipo de instrumentos usa para nivelar a base de la antena?
So for all of the antenna leveling for the polar masts as well as going along with those with the sign mounts, for the other monuments, typically we just use a high quality spirit level. You know, that tends to get us close enough. We just make sure to use it in multiple orientations so that the leveling is 360 degrees.
¿Qué tan efectivo es el aislador de rayos que va en el cabo de la antena GNSS? ¿Y cuánto atenúa al señal? ¿Disminuyen los meteoros y cabo que se puede usar? Yo no entendí correctamente.
So in terms of its effectiveness, I would say that it's good for small charges, but you know, it's not going to hold up against a direct or very, very close lightning strike. As far as cable attenuation, my understanding is that the problem is not from the device itself, it's from the addition of the connectors. So every connector that you use has an attenuation associated with it. Typically, let's see, for if you're using LMR 400, I think the recommended maximum cable length is 30 meters. And there's other tables online for LMR 600 and other things like that. For the GNSS antenna, we haven't seen any attenuation problems associated with using those devices.
Ok, aquí hay una pregunta de Perú. También, ¿cómo podemos recibir asesoría de la instalación de test servidores modelos Leica GR25? Algunos correos de contacto. Bueno, podemos ayudarlo. No sé si Annie.
So it's not a service that we typically provide. And I have to admit, I don't have personal experience with the Leica instrumentation. So I don't have a specific recommendation on that. I'm sorry.
Ok, gracias, Annie. Vamos a intentar ayudar, Manuel. ¿Cuál es el mecanismo de el enlace que se debe realizar para reactivar algunas estaciones CocoNet que se encuentran fuera de funcionamiento en caso de Venezuela?
Wow. So Venezuela has been a very big challenge on my mind. I would love to hear any ideas, any opportunities for collaboration that anyone out there might have. Yeah, those stations have been offline for a pretty long time. CN41 is the only one that's still currently online. A couple of those stations I don't expect we'll be able to bring back all that easily because they don't have a viable communications option. That would be CN43 and CN49. But some of those other stations, I'm very eager to get them online if we could find a way to do so. So please, if you know, please email me if you have information that might help. Or if you're in Venezuela and would like to collaborate on these stations.
Sí, ok. Yo entiendo que sería muy importante tanto de parte de UNAVICO como del país o de la institución donde está la estación que ayude a UNAVICO a mantener las estaciones. Ok. ¿Puede compartir el contacto de personal de CocoNet? Sí, Annie.
I'm sorry, what was the question?
Y si puede compartir el contacto de personal de Coconet para colaborar con estaciones en la costa del Pacífico de Guatemala.
I'm that contact on the UNAVCO side, and we have been working with IGN in Guatemala to try to work on those stations, and also in Savume.
Bueno, aquí yo voy en la última pregunta porque ya pasamos ahí unos 20 minutos. Siguen las preguntas. Yo creo que podemos enviarle las preguntas que hay todavía por aquí y para que tenga la posibilidad de contestar. ¿Es efectiva la instalación de un course del año al mar y la latitud del lugar es similar a del nivel del mar? ¿Es la altitud del lugar es similar a la del nivel del mar? Si hay mucho camino, es propenso en estos lugares.
I'm not sure what this person means by is multipath correct, but in these cases, we do use the multipath from the ocean for reflectometry surveys, which can be used to calculate sea level changes. So it's it's used as a non-mechanical tide gauge in these cases, just by looking at the multipath signals.
Sí, están aquí preguntando sobre Starlink Internet. Yo creo que es Vsat. Fue la misma pregunta que fue hecha antes. ¿Cuál es el mejor proveedor de Vsat? Pero yo creo que no tenemos. En la instalación en aeropuerto, ¿cuál es la mejor opción?
Is this a question from Carlos about Starlink? Carlos, we are actively testing Starlink right now. I'll let you know what we come up with.
Sí. En la instalación en el aeropuerto, ¿cuál es la mejor opción de estructura de la antena? Considerando que algunos sectores deben cumplir con que la estructura debe ser frágil, que antes de un golpe debe romperse.
Oh, that's interesting. I haven't seen that as a request before at the airports, but it makes a lot of sense that they would request that. I mean, typically at the airports, we have used the short drilled braced monument. That being said, you know, it's at some airports. This is where a building mount is actually a good option. If possible, to find a site that's far enough away from the runway so that requirement isn't in place, might be a good option. We haven't done any structural testing on what it takes to damage these monuments, but I mean, I know of one that I saw in Ohio that somebody ran into it with a big tractor mower, and it broke the leg off of the monument. So I would imagine that an aircraft strike would not the aircraft would come out better than the monument in that case. But I don't have the technical detail that the airport permits might require in that case.
Sí, gracias, Jenny. Bueno, yo creo que ya pasamos un poco más. Estamos en una hora, casi 30 minutos de taller. Bueno, vamos
It's been a
quedando.
lot of fantastic questions. Thank you all.
Sí, sí. Las próximas preguntas son más a respecto del firmware que nosotros podemos contestar. Bueno, Annie, más una vez, muchísimas gracias por estar con nosotros, por ter aceptado nuestra invitación y espero que tienes la posibilidad de estar con nosotros en los próximos días. Y gracias a todos por estar aquí. Hoy tuvimos una muy buena audiencia y esperamos estar con todos en lunes cuando vamos a hablar un poco de la configuración de los equipos, de los receptores y un buen fin de semana para todos. Muchas gracias. Saludos.
And I thank you all very much too, and thank you to Jose and Sonia and everyone else for the invitation. It's really been a pleasure to be here.